All right, so 8.4, inscribed angles. So the difference, the last time the central angle, the angle was coming out of the center of the circle. An inscribed angle has the vertex, let's see, on the circle. And you can see like the point B is actually on the circle. Okay, so that's an inscribed angle. So what we have to kind of note is where that angle is, and then find the arms, I guess, or the lines or the chords that come out of it. And that marks this arc that goes with it. Okay? So you kind of have to find the vertex, follow the pathway of the two chords, okay? And then you can see where the arc is that goes with it. Okay, it says, all right, so two sides that are chords, I think I mentioned that. Okay. An intercepted arc, that's the arc that I was just telling you about that lies between those endpoints. Oh, I guess that's the next word, endpoints. The end points of the inscribed angle. So in this case, this would be arc AC. So the measure of arc AC is what we're talking about here, A to C. Okay. The degree of the inscribed angle is equal to 1/2 the measure of its intercepted arc. So yesterday we talked about the central angle being the same as the arc. So here's the center. So if I have a central angle, okay, that's going to be the same as the arc. If those were rubber bands and I put my fingers on the center and pulled it to the side, I'm going to stretch that angle. That angle becomes now half as big.
Oh, neat.
Okay? So the angle is half as big as the arc. The arc remains the same, right?
So to find the arc, you just multiply the angle by 2?
Yes.
Cool.
Or to find the angle, you divide the arc by 2.
Sweet.
Okay? All right. So intercepting a diameter. So what is the degree measure of a diameter? What's the degree measure of a diameter?
180.
180, right? Let's say, we call it a semicircle, but if an inscribed angle intercepts the diameter, then it is a, what angle? So what would be the degree measure of the angle that's intercepted? If it's half as much, what would be the degree measure of the angle that intercepts the diameter? Yeah, diameter is 180, so half of that is 90. And what's a 90-degree angle called?
Right.
It's a right angle. Okay? So if your angle that's on the circle, or the inscribed angle, if you follow along the chords and the endpoints form a diameter, you should have a right angle, which is 90 degrees. So what is the measure of angle BAC? BAC, 90 degrees. Oh, so wonderful. So nice. All right, let's see, where are we? Oh, a little down here. We'll get crazy. Overlapping arcs. All right, so I've got an arc. Well, let's just read the words here. If two inscribed angles intercept the same arc. So for example, like angle A here, its arc is B to C, right? You follow the lines, right? B to C. Okay. And then we go to angle D, follow its lines, it's the same arc.
Whoa.
Right? So take a wild guess.
They're the same.
The angles are the same. Okay? So we'll say congruent. Yeah, the angles. I mean, that's it's kind of a transitive property, right? If two angles intersect the same arc, right? Then those two angles are the same. It's kind of like one item being congruent, or two items being congruent to the same thing.
That's pretty neat.
In this case, they're half as much.
Couldn't you use that then to say that A and D are equal, equivalent, like transitive?
Right, that's the rule.
Oh, cool.
Look at Trey just getting all crazy with his terms.
Dude, I could do a proof of this stuff.
You could. And you shall.
We're gonna do proof.
No, just kidding. All right, so what is the measure? Listen, the measure of angle ABD. Oh, we're going, so I gotta erase some of this. ABD, so we're looking at this angle right in here. What's that measure? What's it congruent to?
ACD.
The measure of angle
ACD.
ACD. Okay, so those would be two angles that are the same. And I'll just color them in for visual effect. Okay, those two angles will be the same. All right, example 1. Find each angle and arc measure. Oh, so if I guess we'll just find the piece of information that's asking us for here. All right, so I have an arc of 62 degrees. So if I travel along the endpoints, follow their lines, and see where they meet. Oh, they meet here at this angle X. Is that angle WXY? Yeah, that's the angle. So what is that measure? If 62 is the arc, what's the angle?
31.
Oh, okay. Right? The angle is half the arc if it's inscribed. Visually, it'll look smaller than the central angle, right?
Visually, it's not.
Okay. All right. Anyway, let's see. We want arc DGF. So we want the arc from D to G to F.
226.
So the angle associated with that arc is 113. So if that's the angle, we have to times that by 2 to get our arc.
Whoa.
226 degrees. Since it's larger than 180, it's called a major arc. Oh, what do we got here? Measure of angle PQR. PQR. So that's this angle right here.
It's 90.
How is it 90?
Because of the thing, intercepting a diameter.
It intercepts the diameter, yes.
These are like
So 180 divided by 2, 90. Oh yeah, that rule.
These are just little mini proofs.
These are mini proofs. Okay, we want the arc BC. We want this arc. Well, it doesn't have an inscribed angle. So what does have an inscribed angle? A to C, right? So we know A to C. What's A to C?
Half of 47.
No, it is not.
Double.
94. So this one's 94 degrees.
Just subtract 94 from 180.
Yeah, because together,
Oh!
together, 94 and this arc we're looking for, that should equal 180 because we have this diameter right here, right? So what's 180 minus 94? 86?
Yes.
Wonderful. Let's see, what's next? Angle JKL. JKL. We want this angle right here. Do we know the arc? We don't know the arc.
Oh, but we can find the other one.
How are we going to find it? We have these other two. All right, so all the arcs together are 360, right?
Yeah.
So if you minus off the 65 and minus the 53, then what's left would be your arc of JML, right? So what's 360 minus 65 minus 53? 242? Okay, so then what's the angle? Half that, right? 121. Okay, these are the types of questions you're going to get where you have to manipulate around to find an angle or an arc in order to find an angle and an arc. So some of these have a little more work than others, but let's see what we have here. RST is this angle, and RUT, oh, we want those two angles. What do you know about those two angles? They're equal.
Equivalent.
Right? They go with this arc, R to T, right? Both of those. So we need to find the arc, RT, and then we can find the angles.
Plus 75 plus 139.
So what do we know? You said 64 plus 139 plus 75. What are you going to do with that? Add them together. Yeah, so the whole circle minus whatever those three are. So someone do that on their calculator for us.
It's 82.
That's 82?
Oh, yeah, that's not nice.
And so,
It's 82.
and then we divide those by 2, right? Because now we're talking about the angle that we want. So each of those will be 41, because they're the same. How much fun is this?
So,
Yeah, not bad. Now let's throw an expression in there. So 8x minus 9 is the angle. The arc is 158. What's the relationship between the angle and the arc? So angle is half the arc, or the arc is twice the angle, right? So you get to do either way you want. You want to, I think I did it this way. I just doubled the angle and set it equal to the arc. Since the arc's an even number, you could divide it by 2 and set it equal to the 8x minus 9. So divide by 2, so 8x minus 9 is going to equal, what, 79? Add 9. So 8x is going to equal 88. So x is 11. So is that what it wants to find? Find each value or measure. So if x is 11, what's the angle? We already know it's half of 158, right? 79. Yeah. You plug it in.
Why do we
make
have-
sure.
Why do we have to do the equation then if we could just...
Well, because it says solve for x.
We're going to say something.
When I just told you, solve for x. Find each value or measure. So the value of x.
I got you.
If there's an x out there, you're solving for it. And whether you end there or have to you plug that back in somewhere is different. But anyway, always plug that back in to see if you're right. 8 times 11 minus 9, you know that should be 79. And if it is, then you're going to be good. What about this one? We have the angle of 67 and the arc of 4x plus 58. What do you want to do? 67 times 2 equals 4x plus 58. That looks like an easier route to go than to try to divide 4x plus 58 by 2 and then set equal to 67, but it's doable still. 67 times 2 is 134. Subtract 58. 76.
Yeah, 76.
What is 76 divided by 4?
What, 19?
19? Okay. So what does the arc measure? If we needed to find it, we already know the angle, so.
134.
134? So plug 19 in here is 4 times 19 plus 58. Does that equal 134?
Wait, why is it doing that?
Why is one doing
On
what?
both of them, the equation, when you did that, it equaled the arc. Like that one equaled 79 and this one equaled 134.
That's. What? What are you talking about?
Not sure, Coleman.
No.
What on earth are you talking about?
So 134 was, we just doubled 67, right? That just gave us this arc. So I'm just plugging in the x value to see if that works. So if I get the right, if my x value plugged in gives me 134, then I know I'm right. Okay, level 9. What do we have here? We need the arc A to C, but the angle is 7x minus 10. How are we going to find the arc AC so we can set up the equation with the angle?
92 plus 160.
Okay, so you're taking 360, we'll write it down here. So 360 minus 162 minus 92. Okay, so 360 minus those two arcs will give me the arc I don't know, which is AC. So what is 360 minus 162 minus 92?
106.
106? Okay, 106. Now, I wrote it down as 2 times the angle equals the arc. But you could have waited to do that and just found the arc and divided it by 2. That's what we're going to do now anyway to solve. So 7x minus 10 equals, what, 53?
Yeah.
Okay, subtract 10. So 7x equals, no wait, add 10. 63. And then divide by 7, so x is 9. And then plug it in, make sure we're right. 9 times 7 is 63, minus 10 is 53. And that is half of 106. Yay! So what you get to do is the same questions. A few of them. Okay, so some of these might make you think just a little as far as, there's a lot of the finding the arcs by subtracting from 360 or 180 or those types of things. So just think it through. Have a good time. Enjoy yourselves. Keep your social distance.